Hello. Can you guys hear me?
Yes. Hi, Mr. Mora.
Honey. Hello, hello. I can't seem to hear any sounds.
Hi, Mr. Mora.
Hi, Mr. Mora.
Hi, Mr. Amora.
Hello.
Hey, guys. Hello, can everybody hear me?
Yes.
Yes.
Can't seem to hear. Something's wrong with my sound. Let me check.
I can hear you.
Hello, hello. Can everybody hear me? Can
Yes.
I can hear
Oh,
you.
okay,
Yes.
okay, much
Okay.
better. Okay, guys. So let's begin by 7:03. So, Sirius gonna be joining. Ika. Okay, one more minute. I'll just check your attendance and then let's begin. Okay, guys, let's begin. Okay, so good morning, not good morning, but good evening to everybody. So for today, we got two objectives for today, but it's so let me just share my screen. Okay, so guys, can you see my screen? The ones with the blue background. Okay, very good. Okay, so let's begin. So for today, we're going to start. We're going to have like two objectives. This is again just going to be a short meeting for us today. So, oh wait, let me just add a few more. Okay, so let's go back. Okay, guys. So again, so for today, we're going to have two objectives. Number one is we're just going to have like an intro to trigonometric ratio, and we're going also to have some word problems involving trigonometric ratios. And by the way, the assignments with regards to word problems involving trigonometric ratios are already on your can, so you could already check that one out. Deadline for that will be next Tuesday. That will be April 7th. Everybody good with that?
Yes.
Okay.
Yes.
All right. Okay,
Yes.
guys. Okay, so let me just Alexa, stop alarm. Okay, here's one. Excuse me.
10-minute timer stopped on Richard's Echo Dot.
Okay, Alexa, stop alarm. Okay, guys, let's continue. Sorry for that.
6:30 a.m.
Okay. Okay, so could anybody tell me like what are like the three basic trigonometric ratios? Anybody?
Sine, cosine, tangent.
So we got sine, we got cosine, and we got tangent. So these are like the three basic trigonometric ratios. When we talk about ratios, they're actually just ratios of the side, where we have a given angle that is in consideration. So let's take a look at first our sine. Let's say we want to figure out what sine theta is. So I'm guessing everybody already knows this. Sine theta has a ratio of, anybody guys? Haley, would you like to share if you have any idea what sine theta is?
It's opposite over hypotenuse.
Very good. So it's going to be opposite over your hypotenuse. And your cosine, on the other hand, Abby, can you give me what cosine theta is?
Adjacent over hypotenuse.
Very good. So you got your adjacent over your hypotenuse. And for our tangent, JJ, what's our tangent theta? Any ideas?
It would be opposite over adjacent.
Oh, very good. So that's going to be opposite over your adjacent. Now, technically, we actually have 6 trigonometric ratios. So after your tangent, you also have your cotangent theta. Does anybody have any idea of what a cotangent theta is?
Adjacent over opposite.
Very good. So you got adjacent over your opposite. Is that Abby? Okay.
Yes.
All right. Thank you, Abby. And then we also have your secant theta. Does anybody know what secant theta is? Syria, any ideas for secant theta?
No, I don't know, Mr. Moore.
That's okay. That's okay. So secant theta is, could anybody like maybe help secant, Syria do the secant theta? Guys?
Hypotenuse over adjacent.
Hypotenuse over adjacent. Very good. Abby again. No? Yeah, Abby's on a roll.
Yes.
Hypotenuse over your adjacent. Okay. And of course, for our last, we also have our cosecant theta, which is just equal to JJ. Do you have any idea what cosecant theta is?
Would it be hypotenuse over opposite?
Very good. So that would just be hypotenuse over your opposite. So these are what we call as our 6 trigonometric ratios. And the last 3, your cotangent, your secant, and your cosecant is what we call as our reciprocal ratios. You might be asking, why are they called reciprocal ratios? Because if you look further, if you just try to change my colors here, your tangent and your cotangent are actually reciprocal of one another. Your cosine and your secant are also reciprocals. And then also your sine theta and your cosecant theta are also reciprocals of one another. Questions, guys, clarifications before we proceed with some examples? Would you like to write it down or give a screenshot?
Yes, please.
Okay, so I'll give you guys like about a minute or 2, then we're going to proceed. I have, who else do we have? Okay, guys, your time. Can I erase the rest? Just for the few, like our sine, cosine, tangent, or let me just like, I think we still got enough space. I think I'll just continue. So let's say we're going to add, let's try to work at some problems right here. I think these are just problems that we did, that you guys did last week. So I'm just going to add some image. Dual course, 3 ratios. Okay, can you guys see this one?
Yes.
Okay.
Yes.
All right. Okay. So, okay. So let's begin. So let's say we have here angle alpha, and then let's try this, guys. I'm going to ask you, what do you think is, let me just change my color to a more brighter one. Let's try this one. Okay. So let's say I want you guys to give me what is sine alpha. Any ideas of what you think is going to be your sine alpha?
21 over 29.
21 over 29. Why do we have 21 over 29 as our sine alpha, JJ?
Because sine, the function of sine is opposite over hypotenuse.
Okay, so you got your opposite, which is your 21. And then you have your hypotenuse, which is just going to be your 29. So let's say, very good. So let's say we want to find out, let's say this is now going to be my angle beta, and I want you guys to give me what is going to be our, let's say, tangent beta. Can you give me what's our tangent beta for this one, Haley? Haley? Where's Haley? Haley, guys? Haley, can you hear me? This is going to be your beta. Okay, this is going to be your angle beta. Again, going back, your tangent is just your opposite over your adjacent side. So, Haley, what's going to be your opposite side for this one? Haley? Haley's not there? Okay, let's try on Syria.
So it'd be A, right? A.
Okay, what's your opposite? What's gonna be the opposite of your angle beta Syria? What's the opposite side?
Oh, so it's 20 over
20 over your adjacent side will be
21.
very good. So you have tangent beta will just be 20 over 21. So let's try something else. Let's say this will be our angle theta, and I would like to ask for my cosecant theta. So what's going to be the ratio of our cosecant theta? An idea, guys? Let's try on Haley again. Haley, are you there? Oh.
Audio isn't working.
Oh, okay, okay. So, Haley, would you like to give us what's going to be our cosecant theta if this is going to be our theta in consideration?
It'd be 20 over 29. The hypotenuse is 29.
Okay, the hypotenuse is 29. And then your opposite will be?
Would it be, wait, 20 or 20?
20? What? What's going to be your opposite for this one also at the same time?
29.
29. So therefore, cosecant theta will just be 29 over 29, or cosecant theta will just be what, guys?
1.
That will just be equal to a value of 1. Easy, right? Questions, clarifications with the review on trig ratios?
Nope.
Nope. You guys good? Abby, Shreya, JJ, Julie, Haley, you guys
Yes.
good? Okay.
Yes.
Yes.
Good.
All right. So can we continue to do some, is it okay if we do some examples that involves word problems involving trigonometric ratios? You guys good on that?
Yes.
Okay, I guess. Just, okay. Here we do have some, there's some, I am having going to get into the live classes on Easter. Anything? Let me just answer some text, guys. There's a few students that couldn't join. Kindly repeat. I think I might have to turn this up. Okay. So let's do some examples. Okay, guys, can you see my screen? It's a right triangle trigonometry word problems.
Yes.
Yes.
Okay. So let's try to solve some problems right here. So this is problem number 1. Okay, so Bugs Bunny was 33 meters below ground, so I guess it's underground, digging his way towards Pismo Beach. Okay, when he realized he wanted to be above ground, okay, he turned and dug through the dirt diagonally for 80 meters until he was above ground. So the question here is, what is the angle of elevation in degrees of Bugs Bunny's climb? So what we're actually looking for is this angle right here. Okay, so we could solve for this angle right here by doing or by using our trigonometric ratios. So guys, this is our angle in consideration, and we have actually two sides that is also given. We got a 33 and our 80. What you guys think is our size that is actually given, like in terms of trigonometric ratios? What ratio are we going to use? What trig ratio we're going to use? Ideas?
Sine,
Sine. Why is it sine?
because we have the opposite and the hypotenuse.
So we do have the opposite and your hypotenuse. What's going to be the value? What's going to be the value on sine? What's going to be the value of our opposite, guys? Any ideas?
33.
Haley? 33. Very good. So we got 33. Then what's going to be the value of our hypotenuse?
80.
So that's going to be 80. So therefore, sine theta is equal to 33 over 80. But we're not looking for sine theta. We're actually looking for our theta right here. So how do we do that? Theta. Guys, let me just, someone wants to, I'll do that later. So we got theta is equal to arc sine. Okay, so we call this as arc sine 33 over 80. So when we want to find the angle, we do the arc sine. So we're going to use our calculator. So guys, please try to remember that's arc sine 33 over 80. Okay, so again, we're not going to press sine. Instead, we are going to press arc sine. So we do arc sine, okay, 33 divided by 80. Okay, you guys good on that? And
Yes.
press equal. So therefore, okay, it's asking here. So guys, make sure also that you are on the mode on your, the mode here is on degrees. So make sure that it's on degrees. So therefore, we now have arc sine is equals to 33 over 80. And that will just give us 24.36. So what should we do it in terms of the nearest tenth, guys? What's going to be the value for our angle?
24.4.
So that's going to be 24.4. Before I press on the answer, I would like you guys to make sure you guys have this part just yet. I'll give you guys like about a minute before I press the check button, and then I'll answer some messages first. That's oh, okay. So we do have
Mr. Moore, I think you're on mute.
Yeah, I can't hear you.
Neither can I, Mr. Mora.
Oh, I'm muted. Okay. Can you guys hear me now?
Yes.
Yeah.
Okay. 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 Okay, guys, let's try to go back. So, okay, so this is our problem. So we do have, okay, so Galileo wanted to release a wooden ball. So he wanted to release a wooden ball, okay, and an iron ball from a height of 100 meters, okay, and measured the duration of the fall. So I'm guessing he's looking for the time. Okay, he found a plane with an incline of 12 degrees. So the incline is about 12 degrees that he could climb until he could get an altitude of 100 meters. So just to give you guys an idea of how tall or how tall 100 meter is. That's about 300 feet. Okay. So how far should Galileo walk up the inclined plane? So technically, we are looking for this value right here. This is our hypotenuse. So we want to find out what would be our length of our hypotenuse. So guys, what do you think is going to be our function for this one? What's going to be our trig function for this one? Any ideas? Yeah, so this is going to be your sine. What's going to be our angle? Guys?
12.
12. So we do have sine 12 degrees is equal to, okay, we do know that it's opposite divided by your hypotenuse. So this one will just give us sine 12 degrees is equal to, our opposite is 100 over our hypotenuse. Let's just try to call this as h. So guys, how do we try to solve for our h? What's going to be our first step? Any ideas for this one? Haley? Oh, Haley's not there again. Abby? What should be our first step? How do we get h? What should we do first? Any ideas, guys?
Would you multiply h to each side?
So we multiply h to each side. So if we multiply h to each side, we would cancel h on the right, and that will just give us h multiplied to sine 12 is equal to 100. What's going to be the next step?
Divide by sine 12.
Divide both sides by sine 12. So we divide both sides of our equations by sine 12. So therefore, we now have h is equal to 100 over sine 12. So let's try to do that on the calculator. Let's just press AC again. Okay, guys. So we have 100 divided by, okay, sine 12. Any questions, clarifications? So let's, okay, so this is again very, very easy. So let's do. Okay, guys, so what's going to be our value for this one? It says here, round off to the nearest hundredths. So what should we place as our answer?
480.97.
Okay, so that's going to be 480.97. Is good? Let's try to check if our equations is correct. Then we're good. Questions, guys? Clarifications before we proceed?
No.
Okay, so I'm gonna have you guys screen capture this one just to make sure that you guys have this on your notes for clarifications. Then I'll give you like about a minute and then we're going to continue.
Mr. Moore, I'll be right back.
Okay, okay. Any questions, clarifications? Just by the way, on Algebra 2 class, you also have like an assignment for your CAN, and then also there's also an assignment different for your pre-calculus class. Okay?
Okay.
All right. 30 seconds more. And 8, 7, 6, 5, 4, 3, 2, and 1. Okay, guys, let's continue. Let's proceed to the next problem. Okay, here's one. Again, it's almost very, very similar. Okay, so we have here, oh, I think we just did this. Or not yet?
No, not yet. It's just
No.
similar.
It's just similar. Okay, so we have here Bugs Bunny was 42 meters below ground, digging his way toward Albuquerque. Okay, that's good. Okay, when he realized he wanted to be above ground, he turned and dug through the dirt diagonally for 100 meters until he was above ground. So, okay, what is the angle of elevation in degrees of Bugs Bunny's climb? So we're looking for this angle right here. So guys, what's going to be our trigonometric function for this one? Any ideas?
Would it be sine?
That would be sine. So if we have sine theta, your opposite will be your, what's going to be our opposite, guys?
42.
Very good, 42. And your hypotenuse would be?
100.
100. Very good. So therefore, your theta will now be arc sine 42 over 100. So let's try to do that on the calculator. Okay, so we now have arc sine. Let's just press it. So we have arc sine 42 divided by 100, okay, is equal to, okay, 24.834. But we're asking the value is asking for the nearest tenth. So what should be our value for our degrees, guys? Any ideas? It's asking for the nearest tenth.
24.8.
24.8. So that's going to be our nearest hundreds. Okay, and then let's try to check. Okay, good job. Questions, clarifications, it's very, very easy. You guys good?
Yes.
All right. Okay. Let me just. I got. Okay, guys. Okay, we're going to proceed with our last example. Okay, so let's try and do this one. So for this one, okay, So Howard is designing a chair swing right. Just change my, so it's designing a chair swing right. The swing ropes are 5 meters long. So this is what 5 meters is. And in full swing, they tilt in an angle of 29 degrees. So this is about 29 degrees. Okay. Howard wants the chairs to be 2.75 meters above the ground in full swing. Oh, this is 2.75. Okay. Now the question is, okay, how tall, okay, how tall should the pole of the swing ride be? So how do you think should we do this, guys? So let's try first to simplify. So we have a triangle. We have a right triangle right here. Okay. So this is about 2.75. Okay, this one has an angle 29 degrees. And this is about 5 meters. I'll label this as X, and I'll label this as Y. So this one has a little bit of a challenge. Okay, what do you think are we technically looking for? Are we looking for your Y, or are we looking for our X? Any ideas?
Is it Y?
Why is it Y?
Because it's saying how tall
So it's
the
asking.
how tall the ride should be.
Okay, very good. So we're looking for the Y because we're asking for how tall. Okay, so that's our giveaway right there. So guys, this is 29 degrees. This is 5. What do you think should be our trigonometric ratio for this one? Any ideas? What's going to be our trig ratio for this one, guys? Syria, would you like to give an idea? So we got a hypotenuse, and we also have, what is this part? That's your adjacent in respect to your 29 degrees. So what is the ratio that has a hypotenuse and an adjacent at the same time? What's going to be your ratio, trig ratio?
Cosine?
Sine.
Okay, cosine. So that will be cosine. Very good. So that will give us a cosine. Again, guys, cosine is adjacent, which is your y, okay? And your hypotenuse is your 5. What's the angle for this one, guys?
29.
So that will give us a cosine of 29, okay, is equal to y over 5. What's going to be our first step for this one, guys? How do we get y by itself?
Multiply by 5.
So we multiply both sides by 5. So we could just cancel this one out. So therefore, our y will just be equal to 5 multiplied to cosine 29 is equal to y. So let's use our calculator. So we now have 5. Let me just 5 cosine 29, and that will now give us what? Oh, my bad. I have to place up. Oh yeah, guys, just be careful. We need to do the multiplication sign for this one. 5 cosine 29. And that will just give us 4 point. Okay, it's asking for the nearest hundreds. So y is equal to 4.37. Are we done or not yet done? Is that what we are looking for the problem, or is there something else that's missing?
Something missing.
Guys, so what else should we do?
I have no idea.
Okay, again, let's
We find X.
we're looking for how tall, right? We're looking for how tall for this one is, right? Yes or no?
Yes.
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 Okay. What is y? Y is only up to this part. This is 4.37, but we're looking for the total length. So what should we do, guys?
Oh, add 2.75.
So we add 2.75. Do you guys get the idea right now? We're going to be adding,
Yeah.
this is also
Yeah.
2.75. So in order for us to find the total length, we need to add 4.37 and 2.75. So let's try to add plus 2.75. And that's going to give us an answer of 7.12. Wow, that's a very tall swing. Oh, about 7.12 meters. Questions, clarifications, guys?
No.
No. No.
You guys got the idea where we got our 2.75? Again, we're looking for how tall our tower is. So we're just going to add 4.37 with 2.75. So that's just going to give us a total of 7.12. Let's press check. And we're all good. Questions, clarifications for our lesson for today?
Nope.
Okay. So I think that would just be all for today, guys. Again, it's another simple lesson. Next week, we are now going to start with trigonometric identities.
Oh, jeez.
Oh, jeez. Okay, it's a little bit challenging, so we might consume the entire hour for next week, but for now, we're not going to be consuming the entire hour. So you guys got your equations, and after that, I will also be sending. Do you guys still have your cheat sheet for your trigonometric identities? If not, I can give you one. I'll send it via your.
I do not have one, Mr. Moore.
Okay, so I'll send one on the Google Classroom. Then after that, don't worry, we're not gonna deal with those really hard ones. We're just going to be dealing with simple trigonometric identities for next week. You guys good?
Okay.
Any
Yes.
questions? Okay.
Yes.
Yes.
No.
No questions, clarifications. Have a wonderful evening, guys. Keep safe. Stay away from the corona.
You too, Mr. Mora.
Two.
Have a happy
Easy.
Palm Sunday.
Thank you. Oh, yeah, is it already Palm Sunday this week?
Yeah, it's Sunday.
Oh my goodness.
Dang.
Oh, today is Monday, Thursday. Oh my. Okay. Thank you for reminding. Thank you, guys. Have a wonderful evening.
Bye.
You
Hi,
too,
Mr.
Mr.
Moore.
Moore.
Bye. Bye,
Bye, Mr.
guys.
Mora.
Bye. Thank you. Bye. Okay. And how do I end? Okay. There we go. And then I'll end my meeting.